All right, I think we are live on YouTube now. I got the YouTube chat up. I got the Zoom chat. Okay, and I'm going to post a reminder to the Discord channel. Actually, I want to post the invite link to the Discord channel first. Hi, Nicholas. Hi, Aaron. There's the Discord invite link. I actually got this problem from today off of the topic suggestions in the Discord group. So it's an active Discord group for anyone that's not aware. It's pretty active. Hold on, I'm gonna refresh the page. Cool. All right. Yes, that's the Discord invite, and I need to give them a heads up that I'm live. I should share with you guys what we're going to be covering today. This is from like a real interview question. I think it's with Uber. And yeah. So only requirement is like, hey, it looks like this. We're starting to overload the health check-in point, and we need to not overload it. I need the link to this channel for inviting the Discord group. Cool. All right. I've given them a heads up. I see the question of why do I stream so late? So there's the leak code contest every week from around 7:30 to about 9. And I need like a good hour or so break after that to like just kind of like, I don't know. I don't want to have like 3 hours of like work like straight. I just kind of need a little break after the leak code contest. And I need the time to be kind of consistent too. The leak code contest does move up or down by about an hour. I could either have the stream before the leak code contest or after. For some reason, I actually used to have one before the contest and another one after. I used to do two every weekend. That turned out to be too much, and I was going to kill one or the other, and I chose the first one because it made it friendly with India Standard Time. So if I did it at like 6 p.m. Pacific time instead of 10:30 Pacific time, it would be something like 6 a.m. over in India, which would just like they would not be a fan of that, I'd imagine. So instead I kept the 10:31. And then it's not very friendly with London time, where I do have viewers in London. I have a friend over there actually, and it's also very unfriendly with Eastern Standard Time. If I was going to change the time, I'd probably change it to 9 a.m. Pacific time. That's actually what time a lot of the other tech streamers on Twitch like to do, like Primeagen, the Prime Time, and Theo, and I think also Trash Dev, maybe a couple others. They usually stream around 9 a.m. to noon Pacific time because it just works really well with all the other time zones. So if I was gonna bump it, I'd bump it to 9 a.m. Pacific time, but then I'd have to be up for 9 a.m., which would be pretty tricky. I'm not a morning person, unfortunately, and I'd have to get really serious about this. So I was really gonna be doing these streams at 9 a.m. because I'd have to like get up at like 7, start reading my material, to just start getting ready for this stuff at 9 a.m. And I'm just like not a morning person, so that would be tricky for me. I'd have to be a lot more serious about this to do that. Um, yeah, all right. I'm gonna try and get this more visible on the screen. Uh, what's the zoom on this? There we go. This could work. This could work. There we go. All right. I'm gonna give it 5 minutes before we kick things off. Yeah, I'll see you guys then. I'm gonna get like a drink or something. And go over the notes I've taken. I'll see you guys at 10:45 Pacific. All right, I guess I'm good to go ahead and kick things off. I see a lovely joke in the chat about you know what, I guess, yeah, I guess I can go ahead and copy paste this. So I'm he's making a joke about something that I said on the Discord, which was so I have a bit of a JavaScript background and I'm actually a fan of React JS. And when I started at my current company, it was like the first major design discussion, first major design decision, probably the biggest design decision I've had to make at my company. And it was just kind of like picking out a framework that I'd be working on for a project. And I just totally flopped on this decision. It was probably just it was like just totally dumb. I've kind of stapled my hand down using this thing called Python. It's so as opposed to React.js or Svelte or some kind of sane front end framework that I'd be used to working with. Like, so I've used React.js for like 3 years. And instead of picking a sane framework, I somehow managed to staple my hand down to working in this thing called Streamlit. And this is why it's absolutely the best framework on earth. That's sarcasm. It uses a procedural paradigm. So it's not really written for front-end engineering. It's actually like just it's not designed at all for like real front-end development. It's designed for people that don't know how to do front-end development and just want to be able to pound out this like really easy thing that has some kind of dashboard with some like charts and stuff. And it's mainly oriented for like data analytics kind of stuff. Like if you're just like an extraordinary Excel spreadsheet power user or something, or you're just doing a crap load of stuff with pandas. And so people that do that kind of stuff are very used to working in a procedural mindset. And so this framework's designed in a procedural paradigm, whereas all the sane front-end frameworks are written in a functional paradigm. Like with React.js, every render, it's like it's re-rendering a whole page. It's instead of thinking about how to change from one screen to another, it's more like it re-renders the entire page itself, like just the whole page, just basically re-renders every single time. It's very functional programming paradigm with React.js, but with Streamlit, it's procedural. It's the worst way to go. And yeah, I've really been having the time of my life with it. It's fucking awful. It's really fucking awful. Even Django would be better than this, I think. It just, yeah, I made a really poor decision there. Okay, we can go ahead and move on. So this is not exactly the sexiest problem ever, but it's a real one that somebody had actually posted in my Discord group. It's I think they got it at Uber, and I get the impression that this docx is like the full context of like what they got for it. It's really cool because it's actually kind of realistic. Is that like, so you got this set up as how the current service is supposed to look. You got this little proxy that the services are using to talk to each other. And it's set up in this like service mesh framework as opposed to like a normal microservices framework. And they're doing these like health checks against each other. And as Uber has grown, we're at the point where the number of health checks is starting to overload the service instances. It's particularly bad for languages like Python. Oh, hey, I'm working in that. I really hate it. It's your first week at Uber and you've been asked to solve this problem. Peak traffic is 2 months away. What would you do? We'll need both a short and a long-term solution. That's cool. A short-term and a long-term solution. The health check is hosted at the service level. In addition to all the endpoints, each service will implement a /health endpoint. And so every service is hitting all of their dependent services at the /health endpoint. And that's yeah, a little different. Yeah, so I think I've got kind of a fair understanding of how to go about it. But again, this is like a newer problem, and this is one of those handful where I'm just kind of a pioneer in the system design space. There's not really anyone else that has kind of covered this before. So yeah, it's I might botch this, but I don't know. We already had a bit of a nice discussion beforehand, but yeah, okay. So it said short-term solution and a long-term solution. So, the absolute best solution might require a crap load of work. So we might not be able to do that right away. And so it's like, if there's a quicker approach that, just tackles the problem a lot more quickly for that 2-month deadline, what is it and how would it vary from the long-term solution? So the first thing that like was spitballed in the Discord group was, hey, you can just do some rate limiting on how often you're calling that health check endpoint. Just kind of call the health check endpoint less, because if the health check endpoint is overloading the services, just call it less. So that's like a kind of a really straightforward thing. I don't think I'm actually even going to draw the whole thing out. A second approach is having this like centralized health check service. So I was thinking that, so we see that all the services have this little proxy box drawn on them. And so when I was at Amazon, they were able to make modifications to these frameworks that we worked on top of, or like these packages or deployment services that we built on top of. And so if they wanted to change, I don't know, some kind of weird background daemon process that like literally the entire company was using, they could do that and just roll it out to all the services. And we might not even know that it happened. And so that's why I was thinking that with the centralized service, you could do something where instead of you'd modify the proxy itself to, instead of calling the other services directly for the health check endpoint, they can just call the centralized health check service, and that can do a little caching trick. So instead of 100 different services pounding the health check endpoint to get their own copy of it, they can get a copy off some read replicas. So I'm going to draw that one out, but the most ideal solution I feel is just proper independently scaled services with load balancers, and not this like service mesh thing where you're hitting each individual machine independently. It's yeah, this is a little weird looking. All right, so yeah, let's go ahead and if there's any questions, feel free to drop them in the live chat and I will try to get back to them. Otherwise, I'm going to go ahead and start drawing out this first, this approach right here, the centralized health check service. It's going to be really similar to the weather app problem that we've covered before. Yeah, so that's going to be the most similar thing to this. All right, so let's first draw out, we're going to say that we have service A that we want to do, that we are going to be checking the uptime of. We're going to actually go ahead and draw out a couple boxes for it. So we've got 3 boxes, 3 different machines for service A. Let's go ahead and draw out a dashed line here. So it's service A. That, and they're all going to have that little proxy box. Okay. Take that there. Like that. Okay, and then we're going to have service B as well. How does the inclusion of proxies modify the problem statement? So my impression was that the proxy is kind of like it's like a deployed package to all the services. There's like the Uber proxy. You could say that the proxy is the Uber proxy. And so all the services are using the Uber proxy. And so you're going to modify code in the Uber proxy. So that way it just is this one uniform little package that is going to be able to be consistently deployed without having to roll out a dozen different versions of it. I think there was something in the problem statement that was HA proxy, well, it said that, but it said something else about this. To avoid writing and maintaining the discovery and routing logic in multiple languages, we offload this work to an on-host proxy P. And so P is going to be the point at which you're going to be making the changes inside of P to call your centralized service. Well, if you didn't have the proxy, you would have to tell all the service owners, hey, in the next 2 months, you have to point yourself at this centralized server. You have to do it. And getting all, like 100 teams or whatever to point at the centralized server. So that was why I was thinking that this might actually be a short-term solution, is that you can just go ahead and modify that proxy thing and get them all to deploy the thing to redirect to the centralized server instead. It's a centralized point of control that can be deployed to all the different services without having to really coordinate a whole lot of stuff with the server owners or ask stuff of them. That was my impression. And so this is different than how I'll go ahead and talk about approach 3 kind of quickly. Is that this looks different than what I'm thinking that usually instead of having this on machine proxy thing, you actually have this this load balancer out in front. I usually use a green box for that. I'm going to use a orange box though. And so usually you have this load balancer out front instead, and you're going to have this request come in. And then it's going to do like a round robin algorithm, or there's a variety of different load balancer algorithms, but it's going to pick the machine for you. It's going to call whatever one has the least load on it for you. And then it'll get a response from that machine, and then it'll send it back. As opposed to over here, it looks like it's calling the machines directly from the diagrams. Your proxy just has a list of the IP addresses directly, is what my impression is. And that's weird. Maybe it's a little bit different, but still it was like, hey, you've got like all these, you have a bunch of different things calling the health check endpoint where it could be brought out. You don't need to have 5 different people ask it. You can just have one ask and then replicate it out, do a whole bunch of replicas of it. And then you don't have 100 people asking the same question within 5 seconds, whereas you can just have one person ask and then everyone checks the read replicas. Yeah. So it was, hey, the proxy is a single point of control that you can use. And this is my best understanding of the problem as well. Maybe somebody else has had this and can interpret it a little bit differently. We've seen that with a couple of other ones. Regardless, I think this is going to be an interesting problem. But yeah, this is my impression of how that proxy varies from a traditional service architecture, is that like the load balancer's off. It's not part of the machine itself. It's like out in front and it picks a machine for you, as opposed to being like on the machine itself. Okay, so we got these for approach 2. We're still using those. And they also have that health check endpoint on them. I kind of want to draw that too. So I'm going to call /health. That's how it was worded in the problem statement, is that it was get on /health. So I'm drawing that box like that. So there we go. Pop that on all of them like this. Let me zoom out there. And there we go. And so we have a whole bunch of different services that are just a whole bunch of them are just hammering you with that, where you can maybe just have one can ask, and then you just go off of the read replica. So instead, we're going to have just one thing assigned with, these are the health checkers. And so you're just going to have one person that is going to hit the health check endpoint. You can either do a pull or a push. So you can either have the data pushed off of the proxy. You could actually have the proxy modified to push the data out to your health check endpoint, or you could have your health checkers that hit the health endpoints. But you know, it's a health check endpoint. I think you should be, all the services I think are supposed to implement this health check endpoint themselves. So I think you do actually kind of need to pull the data off instead of having it pushed out by the proxy itself. Otherwise, you would maybe want to do something like, you would modify the proxy to do something kind of like this, where it calls its own health check endpoint, and then it returns the response out to wherever it's going to have this like read replica thing over here that we're going to use. I don't know. This just, yeah, I think that's maybe not the best way to go. I don't know, maybe we can go into pros and cons of that later, but yeah, so we're gonna have these health checkers that are gonna run, they're gonna hit the health endpoint. And then we are going to go ahead and we're gonna store it over here in the health check status DB. Holy crap, I have not screwed that up like that before. Check status DB. We're going to get the health check status of a given service, and we're going to write it over here. And then we're going to make a whole bunch of read replicas. We're going to make a whole bunch of read replicas to scale up to that volume. So instead of having like 5 different people ask over here, instead what we're going to have is they're all going to be hammering these DBs over here. Or well, so you got read replicas, and then you can also have the health check status service. You should not actually have them calling the read replicas directly. You should have them behind a health. Come on. You should have them behind a health check status service. So instead of hammering this with 5 different people, they're all going to be hammering this, and you can horizontally scale it out like this. And then those ones can, you know, call read replica. The read replicas can be scaled out, while with these individual endpoints, you know, you can only handle so much of it. And if there's 100 services that are dependent on you, you know, 100 different people asking you, as opposed to this thing that you can horizontally scale out like this, this is more ideal. This is more ideal. You just call once, and then you cache it by writing out to a bunch of read replicas that you ask instead. So that is my shorter term solution, is that you have this centralized health check service. And so when you have this proxy or whatever it is that's checking on the health of stuff, instead of having your machines getting this, what you're going to do instead is that you're going to be calling one of these. Have the request come in, it checks the cache of that service, and then it sends the response back out. So we're going to make this dashed. It is the old approach. This is the new approach. And I'm going to draw this as a solid line. And then this is a horizontally scaled out thing. Let's go ahead and mark that these are read replicas. that. Read replicas. And then it is a horizontally scaled out service. Okay, and there we have it. That's approach 2. That's a question in the chat. It is. So with Lambda functions, it's actually really easy. You can actually set them up to you can actually set up Lambda functions just like a cron job. You can have them scheduled, and you will have you will have this set up so that it calls all the services and it's just once. It hits them just once, while on the other hand, when you had it the old way, like 100 different services, if you were dependent, if you had 100 services dependent on you, they would all hit you. While now it's just one call from just the health checker. And I mean, this is going to have to call a bunch of services, of course, but they're all going to hit you just once. But that is the idea, yeah. So yeah, this is yes, and yeah, you can set that up with a Lambda function. And I did show how to make a distributed cron job service in one of my other videos. I didn't want to explain it for like the third or fourth time. I've kind of like done that a few times now, is showing how to draw a whole cron job service. If you're interviewing at like Amazon, like just saying like, hey, Lambda can do that is like totally sufficient for them. At Google, you're going to need to explain it. At Facebook, they sometimes ask you to explain it. They might ask you to explain how to draw that whole thing out. I don't know how non-FAANG companies are, but outside of Google and Facebook, you can just say, hey, Lambda's able to do this. Okay, and there's another question in the chat. I will handle that. I do not understand what was the role of proxies. If someone can point me to this question document, I can read it more carefully. I can try and upload it somewhere afterwards. So this is something that was posted on the Discord group. This was provided to me. I can try and upload it somewhere. I will post that link in the description or the video description, or and in the Discord group. So yeah, there will be a link to this. But yeah, this was just kind of provided for context. Yeah. Okay. Moving on to other things in the chat. Yes, there's the distributed cron job video. Anything that's newer than that also has it might have some nice coverage. And I don't know if I actually have the documents attached right in the description for that video. I apologize in advance if I didn't. I would recommend, if you want to just get the files for distributed cron job directly, I would recommend joining the Discord group, and then there's just in the forum discussion section, you can just find them right in there. You just look up the cron job thing. All right, somebody has some stuff that they're saying in the Zoom chat. No, it was it's like deploying sidecar on each machine. That's what they said of the proxy thing. It's sidecar deployed on each machine. That was my impression as well. That was my impression as well. Will the read replicas have real-time health data? So I remember there was even a discussion about this on the Discord group as well, is that it is eventually consistent. Which meaning you will get scale reads. However, So like the point of like the health check so even in the original approach, you'd only be polling for the health status periodically, like every few minutes, maybe like even if you bring it all the way down to 5 seconds, like, hey, the service could die within that 5 second period. And if you're relying on that service in such a way that you're calling it like 1,000 times a second, which is something that I've seen before in prod, is like, 1,000 TPS is not unreasonable. And if you're only pulling that health status every 5 seconds, your data is going to be stale even there, just in the original setup, which was this one. If you're only pulling it every 5 seconds, it's going to be stale. What's the consequence of that? You're going to have a whole bunch of dropped packets. And so that's going to mean you're going to have a little bit more retries, or you're just going to have some stale reads. Not necessarily the end of the world. Like the whole point of the health check endpoint, I think, is to kind of like, do a little bit of caching, I guess. It's kind of reduce the overhead, I feel. So it's just going to get slightly more stale than it already was. It's just going to be slightly all that much more stale. You're already getting stale reads in the beginning, so yes, you are going to be getting stale reads. But I feel that it's going to be acceptable though. Hold on. Should have, will the read replicas have real-time health data? It should have, else what's the point of its health check service? But you added as a module in your service. So will this be a push happening to health checkers, or will it be a pull-based model? So I am doing a pull-based model. So it is, instead of having the proxy send the data to, so that was an alternative approach. I can draw it out. So the other approach that I was considering was where you have like the proxy kind of hit. So the service is actually kind of like hosted on the machine. And so you can actually hit your sidecar hosted service. And then you would send that data out to the health check collection service, health check data collection service. Oh God, that is actually a little bit of a mess. I'm going to redraw that really quick. So you have the sidecar deployed proxy, and you're actually going to have it do the health checks for you. And then you're going to send it off to this. Like, instead of the health checker, you would have you still have that health check status DB, and instead it would be a centralized service for health status collection service. So you're sending the data to this thing, and then it's going to write it to the database. And that's how you do a push-based model. And I don't know, I just kind of thought that looked kind of goofy. So I think having a proxy do that, I think, is just kind of weird. I think it makes more sense to have the health checker make a call to the health endpoint and just leave the proxy doing like proxy work instead. So I thought that kind of kept it simpler overall, or just it made more intuitive sense to have this pull-based model instead of the push-based model. And then so what if the whole machine's dead as well? Is that you would also then need to have some kind of like TTL in the health check status database, as opposed to in this pull-based model where, hey, if the thing's dead and you're trying to pull it, then you would get that 404 back, or the 50X back, and then you'd be able to like write a false instead of having to rely on a TTL over here. So over here, you'd have to rely on a TTL to know that your health check hits are failing due to a whole machine being dead. Okay, moving on in the Zoom chat. It can't be eventual. That's the whole point of a health service. So your health check hits are still going to be periodic. There still is going to be some amount of stale read stuff to it. So it's like you can't really get away from, like, the only way that you would not have stale reads is like if you're doing a hits the health check endpoint along with every single call you're making to the service, which doesn't make any sense. Like, why would you always be hitting the health checks endpoint on top of your call to the service? That's like redundant. The health check just kind of does some kind of caching trick to reduce. It's more like a circuit breaker thing. The health check endpoint is more like a circuit breaker thing, I think. And it also helps with setting up pager stuff. It's more of like a circuit breaker thing though, and to my understanding. No, whoops. No, it will affect availability, so it can't be a solution. So like if service is dead, it's going to be unavailable. But like when you're calling a health check endpoint and like the service is dead, it's already unavailable. It's I don't know how else to explain this, but like the point of the health check service is more of a circuit breaker thing. You like you can it's not determining the availability of a service on its own. Yeah, I don't know how to better explain it than that, but that's what question, that's my 2 cents. So I might even be misunderstanding something about the question. I like, this was my best understanding of how, like, what the point of a health check service is that it's just kind of involved in some stuff for like making your pager work, and also more effectively cutting down on the overall number of retries involved in trying to get a response from a dependent service. So like I was saying, service B needs something from service A. So it's going to try and get it from this machine. Oh, no, that one's dead. Okay, we're going to retry and we're going to call this machine instead and get a response from that. So if you're using the health check endpoint and you cached the result from here, then when it fails on one of the requests, you know, oh, hey, I'm just going to skip that machine next time and I'm not going to make any more calls to it. So from then on, it doesn't try to call this machine for any data. It tries the other machines for data. It doesn't even try this one, and just round robin across these machines. But like in order to get the most fresh data, you would have to be calling that health check endpoint more frequently. And it just doesn't make any sense to be calling it prior to every single request, which would be what would be required to not have any kind of staleness to the data at all. And again, please explain to me if I'm not actually understanding that right. I'm gonna look at the YouTube comments now. So will service B not talk with health checkers? Will it only send the response to service A, and then it will indirectly send to health checkers? Service B should not be, it will not be calling, so you will not be hitting the health check service at all from the other services after the migration. So under the original, let me go ahead and draw out how this looks under the original approach with like my diagramming is, so what you had originally is just hitting it directly. So you would even have, let's go ahead and have service C, and this is going to be under my more simplified diagrams where you just have like one box, and we're not going to fully draw out all the things on it. So we got service C, and on top of it calls to service A itself, the actual endpoints hosted on it. It's also going to be doing these periodic hits to the health check endpoint that had to be implemented like that. So you got all these other services that are doing that hits the health check endpoint. And these services have that endpoint implemented on top of other endpoints that might have. So let's say that service A is a order placement. So it's the order service. So it's also going to have other endpoints that's hosting itself, such as /order/order ID. It's like get order details. You're going to have order placement. So it's also going to host like post/order. And then you're going to have your like request blob of like order details or the order you're trying to make. These are just like the stuff that the service is actually responsible for. But on top of that, in order to play nicely with all your dependencies, you're also going to have this other required endpoint called /help. And so that one is going to be get /help. And that just, I actually have seen this implemented myself at a different company that I was at before Amazon. And it just would do, when you hit it, it just kind of like checks that its own database is alive. So it would just kind of like, if that service also owned a database of its own, when you have a request come into that health check endpoint, it would just do like a little read request or something. It wouldn't necessarily need to be for actual data. It would just be like maybe the metadata table. So like, for example, if you usually do these heavy key range queries on this thing, instead you would just do maybe like get a single record, or I don't even know how to do something more. You just kind of check this things online and just other dependencies. So the service I worked with actually had like 3 different data stores that was using. It just kind of hit all of them every so often with the health check endpoint. And like, if they're all good and they're not returning a 50X, you go ahead and return a 200 OK off the health check endpoint. So that's usually what it does, is it's just like, yep, this service is functioning just fine. Only send this A, will it send to health checkers? Yeah, so before it was hitting the health check endpoint directly. Here, nobody's talking to health checkers. It's the health checkers that come and fetch data from you. And then instead of calling this, you are just calling the centralized service instead. Talked about K8 problem statement at start. If health check fails, Kubernetes won't even schedule the pods, so that can act as a reliable source, or we are assuming it's not configured in the cluster. Oh, okay. So so Kubernetes might have something built in for working with a health check endpoint. I'm actually not familiar with that at all. So it might not schedule other co-located pods, like sidecar deployed pods, onto the same machine. Yeah, I didn't think about this in the context of Kubernetes though. So won't even schedule the pods, so that can act as a reliable source, or we are assuming that it's not configured in the cluster. So if it's dead, like that would be an indicator to like not call that machine anymore. If the health check is failing, you should be calling other machines in the cluster. And it would also be a signal to like, hey, try and like restart that machine or something for the engineer that's on call for the service. Okay, I'm going to try and move on to approach 3, which is over here. So we've got, this is approach 2. Make that extra large. This is approach 2 right over here. And now we're moving on to approach 3. So over here, we're just going to use a load balancer. It's not sidecar deployed. So over here, proxy is sidecar deployed. It's on the physical machine itself. Over here, load balancers can actually be, there's actually hardware, like actual machine hardware. You can get like a physical load balancer machine. I heard they're like $10,000 or something. You can actually have 2 of them. And you can have them in like an active setup. And so you can actually have like 2 load balancer physical machines in an active configuration that are doing like round robin hits against the machines that are configured for your service. So it's like out, it's like not sidecar deployed, it's separated completely. And then you just have that for each of your services. And you don't need to have a centralized health check service. You would have metrics and monitoring, and you would know if your machines are down, but the other services don't need to know that. So you've got a request that comes into your service B. All right, so you got this request and you need to handle it. It's going to route it to one of your machines. And then this guy needs to make a call to service A. So what's going to happen is that it calls the load balancer of service A. Request comes into the balancer of service A. And then it's going to pick a machine for you. It's going to pick this machine, let's say. That one gives a response back. And it returns that response over to your machine for service B. And then you return your response back out as well. That's how it normally works, to my understanding. And if one of these machines is dead, your load balancer is just not going to send any requests to it. So, you get a request that comes in and it tries to send it to this machine, and this machine is dead. You're going to get a 404, and then you're going to retry. You're going to go ahead and send another request to your load balancer, and your load balancer is going to be like, hey, this one sucks. Let's not send any more requests to it. And then it's going to send one over to this machine instead. It's going to stop talking to this one. That's my understanding of how things traditionally work. If I'm wrong, go ahead and let me know, but that's been my mental model of load balancers for, I don't know, like at least 2 years. I've been pretty wrong before. I mean, I've totally been pretty wrong before, but that's been my mental model of load balancers, to my understanding, is that it picks the machine, and then that singular machine, it's not going to send the request back out through its own load balancer. It can go ahead and talk to other services directly, but it's going to send it to the load balancer of those other services instead. Okay. I think that's everything I wanted to cover for the approaches. I know somebody else was interested in, you know what I want to do? I want to share a link to my excalidraw before I even closed out the video. Like I lag so much on that usually. Like I can literally spin up to a whole week before I actually send you guys the so here's the excalidraw link right now. And I'm going to put that in the video description as well. But yeah, you're not even going to have to wait a whole week, or you're not even going to have to wait until tomorrow morning for that excalidraw link now. I'll stick it in the video description before I even close this as well. Why 404? It's a client error code, load balancer. Will never 404. I will say they will return a 5xx. So you're saying that, let's go ahead and draw this out. Let's go ahead and draw this out. Okay, your request comes in to service B, and service B is like, oh, I have a dependency on A. I need to go ahead and talk to service A. So you send a request over to the load balancer of service A first, and then it's going to talk to a faulty machine. It's going to send a machine. We're going to send a request over here. It's dead. It's dead. So it doesn't send a response back. And then I guess the load balancer could time out. So you're saying that when it times out, it would actually return a 5xx? Load balancer also generally calls the local services health check endpoints to keep itself updated with the active services. So that, okay, that's cool. That's cool. I can believe that. I can believe that. I think you would have to configure that. Well, maybe you can just ping it. So the load balancer might just go ahead and ping the machines to check they're still up. 503. I can believe that, but it would be a ping. So you can kind of have like, so at the company that I worked at, where we actually configured our own health check service, we had two. There was like just a basic health check and a basic health check service. There was actually a deep health check endpoint. So we had like / basic check, and we had like deep check that would actually call database dependencies. But you would like need to configure something on the load balancer to know to check those. I haven't personally ever touched that myself. I maybe just don't know anything about load balancers. I'm sure load balancers do know something about the availability of the machines while they're talking to it. If it does ping those machines directly itself occasionally to check, I wouldn't be surprised. When those machines are sending responses at like, when you have like 1,000 TPS and you're hitting them, that means each machine's probably getting a TPS of like 10 to 100. There's some cases where I think you can scale an individual machine up into the thousands, particularly with databases. So like if it's database that you have a load balancer in front of, like a single machine might be handling 10,000 TPS. I don't even know why you would need to implement a health check endpoint in that case, because you're literally talking to it like more than 1,000 times a second. You don't need to like even pull it at that point. It's like the calls itself is pulling. If it won't ping, how will the service? Whoops. It won't ping, how will the service come back or added to the pull back? Well, so if it's not responding, then that's how you know it's dead. So it's like the calls themselves are kind of like the ping or like the check for whether it's up or not. So it's the health check, I think, is a lot more necessary for when it's a low TPS service. So like if you're only calling it like once a minute, normally, like if you're only calling it like once a minute or something like that, or it might just be an independent thing for your pager for checking the availability and of the machines. Like if your machines suddenly become misconfigured or they max out their RAM or something, then that would make a lot of sense to me, because just because the service is dependent upon you are failing doesn't mean that you yourself will get notified right away. It'll mean that your services that are dependent upon you will get notified. So your partner teams will get notified. and then they would have to page you instead of you figuring it out on your own. So I think that would kind of make sense, is that it's the health check endpoint is more for the purpose of your own pager and figuring out that your services are down on your own without having to rely on your partner teams to tell you that your service is down. Okay, looking back at the YouTube chat and this response thing, it looks like we think that it'll be a 503. It's allegedly going to be a 503. I maybe. I think this is just one of those things I don't know a whole lot about myself, unfortunately. That might be reasonable. I thought it could totally be a 404. You can definitely get like a dropped packet. It's like if there's just like a dropped packet off of like a bad internet connection, that could be a 404. That would be interesting though, is if the load balancer actually sends a 503 when it gets a 404 over here. I'm not going to call you a liar. I just find that shocking that it would translate a 404 to a 503. That would be very fascinating in my opinion. Micrometer / Prometheus setup for health checks application metrics. Any thoughts on that? I think I heard that's one of those things that sets up this kind of stuff on your behalf. So this is, but like the interview question is basically like rolling your own health check and endpoint stuff. So like if you're not gonna, there's a lot of interview questions where they want to roll something from scratch. And so this is probably like rolling your setup from scratch. That's my thoughts on it. All right, looking back at the Zoom chat. If you are just deploying your service, it won't respond for that period of time. Well, so unless that's if you do, you can do what's called a rolling deployment, which is where you only bring down one machine at a time. That's actually how we did stuff at Amazon, is that if you had, I can draw this out. So let's say that you have a service with 6 hosts. So there's blue-green deployments, there's rolling deployments, and then there's like the old-fashioned ones where you just go ahead and shut down the whole service, update the software, and then you bring it back online. So we're going to say that blue is the old version. So we have the old version is blue, and you want to update it to green. So in a rolling deployment, you take this one down, you put the green software on it, and then you tell the load balancer it's good to go. And then you go to the next machine, you take it down, you flip it over to the green, and then you tell the load balancer, hey, it's good to go. And you're just going through that one at a time. And then you have 0 downtime for the service. That's a rolling deployment. The alternative is a blue-green deployment, which is where you got the whole fleet. The whole fleet is on the blue software. And this one's more dangerous, I feel. I feel this one's more dangerous, but it's for stuff where you can't have blue and green up at the same time, which is rare. You should actually be designing your changes that you can do a rolling deployment like this. But you got the blue fleet, and then you set up this second fleet, and you have the green software already installed on it. So your load balancer is currently pointed at these machines. And then you set up all these machines with the new software. And then you suddenly flip a switch, and then your load balancer is instead of hitting let me draw this a little bit differently. So instead of your load balancer hitting this fleet, you flip a switch, and now it's hitting this fleet instead. That's a blue-green deployment. That one's really dangerous because you're just doing a 100% flip over. That's really dangerous. I've seen it done before. It's not super common. A lot of people like to do rolling deployments. They also will do what's called canaries. which is where you play you duplicate some of your prod traffic and you run it through pre-prod environment as a copy. And you see if it sends back, if it fires off 50Xs, and then if the canaries are going fine, you go ahead and do this rolling release or something like that. That's what you would do on a service like DynamoDB. They definitely have canaries set up for like DynamoDB itself, like over in AWS. You definitely do canaries. I think Facebook also does canaries, but you usually don't bring something down entirely for a period of time when you're doing an update if it's something that's very high availability. So I'm just putting my 2 cents on that. But how will the load balancer will know that deployment is complete? So that's like, so with a blue-green deployment, you like tell the load balancer, I think, like when stuff is updated. I haven't been super hands-on with a load balancer myself, to be honest. So like I might be misunderstanding some stuff here, but my impression is that you have to like tell it to update in certain ways. Like it's a configuration thing that you set on the load balancer, I think. So in order to achieve the load balancer pings, or with like what I was saying with the rolling release is that you go ahead and update the machine in place, and you don't actually like have to swap any IP addresses in the config. Again, I haven't been hands-on with the load balancer, unfortunately. How will the load balancer know that deployment is complete? So you tell it, I believe. So in order to achieve the load balancer pings all the services based on configured time and maintains the list of active nodes. I'm fairly certain that it does maintain a list of active nodes. I'm fairly certain that load balancers should maintain a list of active nodes. I agree with that. Which of the approaches are short-term and which one is long-term? So I was thinking approach 2 is short-term and approach 3 was long-term. So we got approach 2 up here. That one is the short-term. And then we got approach 3. And this one is long-term. You're right that your Kubernetes script tell the load balancer start checking in period seconds after the application is up after deployment seconds. I've never been super hands-on with Kubernetes, so I can't talk in terms of Kubernetes stuff. Sorry. Load balancer does low-level network pings not help. That sounds right to me. I can believe that. Yeah, I was thinking it would maybe do pings. It would just use the ping CLI command. It gets those IP addresses. A health check is usually something that's a little bit more of a business logic thing. Health checks usually are a little bit more business logic oriented, to my understanding. And somebody said there isn't. I'm pretty sure this is the guy that had the interview question himself. There's no Kubernetes here. This is this legacy system. So it's like you're kind of rolling everything from scratch here. You don't get Kubernetes. That was my impression as well here. That's kind of what I was trying to like. I was kind of not touching on the Kubernetes stuff a whole lot. I was like, I think you're kind of expected to like roll it without Kubernetes. Also, there was HA proxy was mentioned. So HA proxy is kind of like, I think you would kind of like use that instead of Kubernetes. I'm not super hands-on with infrastructure though, so I again am pretty awful with this stuff. Okay. Going through a couple more comments. We're probably going to drop off here in a couple of minutes. Load balancer can relay response from backend services along with their configured code. Otherwise, they generally follow 5xx. I'm honestly going to look into this. I'm actually really shocked that it might be translating a 404 into a 5OX status. I've never heard of that before. That's totally fascinating. I think it's independent of microservice versus monolith. So with a monolith, you might put a load balancer in front of the monolith. So monoliths just mean that you don't have backends talking to backends. Microservice just means that your backends talk to other backends, like what we have going on over here. So with a monolith, you still might have this setup like this, where you have a load balancer. It's just that the request coming in is going to be from like an end user with like a browser. So like for a monolith, you might have your request come in. You can even have a database, and the database could even be horizontally scaled out. You even have a horizontally scaled out database that you're talking to. So horizontal scaling can still apply to the monolith. It's just that you don't have backends talking to other backends. And microservices are generally they're a tool for scaling up your human resources, your engineering team. It's a tool for scaling up your human effort to a larger number of engineers. It's not like a tool for handling actual traffic scale. So yeah, that's just some context on that right there. There is no Kubernetes here. Just another person saying no Kubernetes here. We have some interesting chat here in the Zoom around deployment. It's generally done via traffic manager in each. Yeah, generally. All right, maybe this will copy properly. Whole switching, which we're talking about around deployment, it's generally done via the green blue thing. Traffic manager in each stamp generally has its own. Every service usually does have its own load balancer. Yeah, so that I had that drawn in approach 3. Each service should have its own load balancer. Yeah, that's correct. The deployments, so at Amazon, the deployment was definitely handled under the hood by a deployment management service that was definitely handled for us, but I was aware that deployments were definitely a rolling deployment. We definitely did not, you were able to see them going down one at a time. You were able to watch the deployment status. And so I was able to see that, like, hey, 3 of the services were updated out of 5. 3 of the machines were updated out of 5. And you would see it like at a region basis that you would have these 5 machines in North America. You had like 8 over in Europe. You had like another 3 over in Asia, in like China or Japan or something. And you would see it going region by region. You wouldn't slap it out worldwide all at once. You would just kind of go one region at a time. And within that region, you would also do a rolling deployment like this. And you were able to see like how many machines have the newest software. Yes, the deployment was handled on our behalf, but I know for a fact it was rolling deployment. And yes, you were correct about each service having its own load balancer. 4xx means service is up. Yes, actually that's true. That's a client error. 4xx is a client error. That's true. I don't remember anybody saying anything about 4x statuses. Wait. Wait, 404 though. What about a 404? 404 might mean the service is down though, because that could be a dropped 404 could be a dropped pad. So it's that could mean that machine is dead. And somebody's saying, nope, they won't translate 404 to 5XX. I agree. I was, yeah. 404 because you said somebody dropped a link over in the Zoom chat. Whoops. Why is it not copying that? Oh my God, come on. Got this. I'll try to pull it up for you guys. Watchdogs. Watchdog is a separate service that can watch health and load across. So that's basically what I was trying to do for approach 2. That's basically what I was trying to do for approach 2. Very interesting. So I'm even going to write that in my notes as, you know what I'm going to do? Yeah, so we're going to copy this link and we're going to go over to this thing. Watchdog service. And very cool. Kubernetes script to tell the load balancer to start checking in. I think. Oh, okay. In a blue-green deployment. Oh, I can see that. I can see that. You're right. I might have had that wrong. Yeah, I think you're right. Blue and green might be separate load balancers. I can totally see that. That doesn't sound, yeah, that doesn't sound wildly incorrect. That sounds totally possible. Yeah, sorry about that. They only do if there's no response from backend. This is looking more at this little conversation we were having. Oh, well, so I might have misinterpreted that earlier. As you said, back and prod node is down and drew a cross, so no response from back, and that's why I suggest it might be a 5XX. That makes that okay. Yeah, I think you're. Yeah, okay. I'm gonna look into that. Route not found. Machine is dead is 502. Gateway timeout. I do not know enough about the way that load balancer communication and reverse proxies work. I definitely don't. You guys are probably right. It might be a 503 back from the. I can see this a little bit more now. I think we've probably discussed this enough at this point. I think I'm okay with wrapping it up. I'm going to drop another link to this excalidraw in the live chat because I've now drawn a little bit more. I think we've probably discussed this enough now though, so I'm gonna let you guys go. Thanks for watching. Feel free to join the Discord if you haven't already. Thanks a ton for watching. I hope you guys have enjoyed this. I will see you guys next time. Thanks again. See ya.